Welcome to the Crazy Hat Chemist. Today we're doing the 18th video on nuclear chemistry, so let's get moving. Bam! So, half-life calculation number 3. How many half-lives have occurred if there was originally 60 grams of a sample and it decayed to 0.1172 grams? So, one thing you could do is you could pull out your knife and slice it in half until you get to that number. That is the following right there. You got 0 half-lives at 60 grams, divided into half, divided into half, divided into half, until you finally get to that number. Now, it just so happens to be 9 half-lives. It's a whole number of half-lives, so it does work out really nice and simple as well. Okay? So, but that seems to be rather tedious. So, I'm going to give you another method. So, I'm hoping that you remember this one here from the last half-life calculation number 2. So, what do we have here? We have the 1/2, that's for sure. We have the original amount, that's the 60 grams, and we have how much remains after a certain number of half-lives. And that how much remains is 0.1172 grams. So I'm going to plug all that in, but what I don't have is the number of half-lives. That's going to be my variable. So the x is my variable, that is the number of half-lives. I have 1/2 to the power of x times 60, the 60 is the original amount, is equal to the 0.1172, and that is how much remains. Okay, so now what we're going to do is we're going to solve for x. We're going to bring that 60 to the other side with a little division problem. That is what we get there. Okay, now this is going to deal with some log base 10 stuff. So hopefully you remember some of that Algebra 2 skills in which you have used before. Maybe they regurgitate that in pre-calc. So here we go, log base 10. Now we still have that power of the x, and we need to get rid of that and hopefully remember some of this. And this is a rule here with log base whatever it is. So log base b times m to the power of c is equal to c to the log base b times m. So what we're going to do is we're going to bring that c, that power, over in front of the log. So that x is going to go in front of the log, and that's what we have right here. Okay, now we need to solve for x. That's all we've been doing this whole time. So we're going to divide both sides. We're going to isolate the x. It's on the left-hand side. We're going to divide both sides by log base 10 to the 1/2. And that's what we've got right there. Okay, now we're going to divide those out, and then we're going to get ourselves an answer. What is that answer? 9. So it is 9 half-lives, exactly. Okay, now I want you to try to do this problem using the half-life equation and the integrated first-order rate law. It still can be done with that one as well. I don't have that here, but you should give it a try. I've given you 2 different examples of solving the same problem. You should always give them a try with different methods. Okay, here's a bit of nuclear humor to tie up today, so watch carefully here. Why did the 40-year-old chemist purchase a motorcycle? There he is, that 40-year-old chemist. Okay, because he was having a half-life crisis. Thank you very much, Jared, for that joke. I appreciate that. Okay, so here is one more thing, and that is I got another cool hat here. This is the moose. The moose is loose, baby. Oh, by the way, thank you very much, Candace and Aaron, for this moose. It has been over 12 years since you guys have given me this moose, and I wear it every year. Okay, I hope you have a great day. Give me a thumbs up if you like that video. Subscribe to my YouTube channel.